groups of these animals, and it's really nice to be able to rely on all this collective knowledge and expertise through this telepresence technology. So yeah, we're looking at a sea cucumber, a holothurian, and this particular family, the Dimorphic, where you have these long projections. And yeah, sea cucumbers are also part of the phylum of the echinoderms. In the same phylum will you also have urchins, sea stars, brittle stars. So they're characterized by having five-sided radial symmetry.
Sure.
And then the sea cucumbers in particular are interesting. Well, actually in the deep sea there's also some free-swimming forms. Most of them, or most people, when they think about sea cucumbers, they think about them just being on the bottom, but there are some swimming forms.
Coming out.
Also interesting is that their body, they're composed of collagen, and they can actually actively change the shape of their body and contort their body into all kinds of shapes. That way you'll be able to squeeze through narrow spaces. Also interesting is that it has been observed in aquaria and in captivity that some sea cucumbers actually can will split into two and asexual reproduce like that, and that's yeah. But several more of these primnoid corals that are seen throughout here. Another one of these mushroom corals, and yeah, we see a little bit of sponge debris and dead sponges in the area. Depth is 970 meters. And yeah, we're getting into places with a lot less life. There's a stock crinoid, looks like it. Maybe we can take a quick look at that.
In upper center.
Yep.
Right, come on in video.
Oh no, that's no need. So that's another young Metallogorgia.
Let's do a quick shot of the head while I'm here.
Yeah, I first thought it might be a crinoid from afar, but yeah, that's definitely a Metallogorgia. So this is another octocoral. And then within its plume is another ophiuroid.
Get pushed back.
Yeah, has the current been picking up?
The current is...
So yeah, we have seen some stock crinoids, Scott, not on this dive, but we did see a few, not many.
My head over the side here.
And yeah, this is the topography we want to follow. Yeah, as we're navigating up this ridge, there's portions where it's more defined and then less defined, and we're trying to find the steepest areas here to.
Wow.
And
yeah, and you can see the marine snow. It's more current.
Port to starboard.
Yeah.
and
Some north in the west.
going to go ahead and update our position here, just to give everyone an idea of.
So what do you see as the strike of that?
Let me get back on top.
I think that move is pretty good. I'm pretty much centered over it.
Something like between 15 and 20, 15 and 25, or 15 and 30, somewhere around there.
Okay, want to do, 30 meters 020.
Sounds good.
Copy that. Calling it in.
Do a quick zoom on this guy right here.
Bridge nav.
Coming in.
I'd like to get a ship move of 30 meters at 020 degrees at 0.2 knots.
Strange little guy.
Yeah, and that's our first urchin of today's dive.
Little baby urchin.
Good copy.
And that looks like Aspidodiadema hawaiiense.
What is that object on top, that darker tan colored thing?
That's the mouth. Yeah, I agree. So, yeah, I think this is Aspidodiadema hawaiiense.
A little bit.
Coming out.
And
Do I get a toe in?
Yeah, trying to. Without poking my eye out. Alright, come on in.
Coming in.
yeah,
Does that remind you of
I
Anchorage?
believe that's the same. Yeah, yeah. So I think that is Aspidodiadema hawaiiense.
Hey, this is Chris. I noticed you're looking at one of my favorite animals.
Oh, excellent. Why don't you share about why it's your favorite animal?
This is just one of the weirdest looking sea urchins that I know of, and it looks like that weird spider robot from Johnny Quest. So it always gets it's always very interesting to me. So these are neat because they have little sort of hoof-shaped or suction-cupped even shaped ends on the spines, and they walk around on them on the deep sea floor. And so that's where all of that weird sort of bowing of the spines is coming from. And I think also to add to the appeal, just from watching this video, I think that little bulb that you're seeing on the top, I think that is an anal cone, which is something that you would see in shallow water diademas. This is not a diadematid, but it is distantly related. And anal cones are where the poop comes out. So I think we might actually be seeing this Aspidodiadema with its poop just about ready to be expelled from the top. So you've got a lot going on here, and you've got some beautiful video footage, getting some really close-up footage of the surface of this animal, which is just remarkable. And on top of that, I think there are different color forms that I've been seeing on these dives, and I'm still a little skeptical that this is hawaiiensis. There's another one, I think, but I'm not sure if they've quite got all of it worked out. But it's just a great image to enjoy of this animal, and and I think the last video you guys took, you got some spectacular video images of the little sort of cups or hooves on the tips of the spines, and those don't come in museum specimens very often. So to see these alive is just a treat, and I'm always and I'm always just overjoyed to get a chance to see
I
them.
wanted to
So.
see the bottom of it. Where it's actually
Excellent. Yeah, thank you, Chris, for sharing that. And now,
Have a good night. Thank you.
out of curiosity, so you mentioned the Hawaiianse and another species. I think he might have just left us. But yeah, that was Dr. Christopher Ma from the Smithsonian Institution, National Museum of Natural History, working with museum collections out there in Hawaii. And so, yeah, he points out how valuable some of these in situ images and these videos of seeing these animals alive, because most of the times when people work in museums and looking at animals just in jars when they've been preserved and they've been highly degraded, and you don't see a lot of the characters that you see when these animals are alive. You lose a lot of characters, and you have to see these things alive and seeing them with their natural behaviors it is a treat and a very rare thing.
These guys are very tough to film. Come on in.
Is that fish or jelly?
That's a fish.
He's
right
inside our light pole.
Yeah.
All right, Bruce, you're on.
I didn't want to say it, but thanks for saying it, Chris.
Alright.
Okay, I've started to come
Unfortunately,
over
I
the top
looked
here.
away for just a moment, and all I
015
saw was a
off
little
this
dark
bridge.
fish swimming up in the water column, so I couldn't see what that was.
Yeah.
As
Yeah,
we
he
come up
was
this, can we get
not
just a
very
slight wag
cooperative.
To starboard, just so we can see that delineation between the rock.
Yeah,
and
we
the
see a
sediment
nice
there.
bigger
Thank you.
sediment patch here to the right.
Oh, that's definitely the biggest sediment patch that we've seen on the seamount so far.
Yeah.
Interesting that it's accumulating there and on a slope. So most of the sediment is most likely pelagic detritus, and the reason that I say that is because the seamount actually does not have a flat top. So usually on the bigger Hawaiian seamounts that have made it to the surface, they've developed a carbonate platform that gives them the flat top morphology. And the sediment that you would be seeing would be a mix between detritus that's dropping out of the water column, as well as some of the eroded coral debris from the tops. And so,
Roger.
yeah, so most of this sediment, I think, is just pelagic snow that is accumulated in this particular area.
And so, yeah, this is going to be a sea pen, and that's in a different group. We haven't imaged these today. That's going to be in the genus Penachula. And I believe that's Penachula inflata.
If we have any more light on it.
And so, and these guys, they have what's called dimorphic polyps. So you have some polyps that are specialized for feeding and others that are specialized for other tasks, such as pumping water. Those that pump water on the back, well, it's now hidden, but actually no, on the top you can see some. Those are the siphonozoites. And then you have the autozoites, which are the ones with the more traditional form with the long tentacles and that feed.
Are we coming closer?
And,
Yeah,
yeah.
no,
I'm sitting down right here.
all right. Yeah. Wait till you settle in here.
So Dan, there's some really good imagery coming out of both the manipulator arm cameras where you can almost make out some sedimentary wave crests.
Oh yeah, excellent.
So we're oriented just about 30 degrees off of north to the
Copy that.
to the
Let
west.
Me just run it by my pilot.
So that means a
Everything's good. When you're
south
ready to go.
southwesterly current, at least in this local direction.
Yeah, good observation.
Little shrimp in there.
And there's some more sponge debris in the background. And some live sponges, yeah, sea pens. common in many places, and in particular in the deep sea and some the.
Okay, looking straight down on the
I'm
pilot.
off the bottom now. All right. Coming up.
Coming up on
Yeah, and you can see there what Jonathan was pointing out, those sand ripples, and those are important because
the ridges off to
they
your
give
port
you
side
some
now.
kind of indication of where the water is coming from. When the predominant water current direction is that you'll start having sand ripples forming perpendicular to the current flow, and so that gives you some kind of indication of where the water. A few more of these massive stock sponges. Depth right here is 960 meters.
As far as rate, we're about 30 meters behind as far as, within a 30-minute time.
Again, we still have about 260 meters to climb till we are at the top portion of the seamount. We do still have 4.5 hours approximately left of bottom time.
Do a quick zoom on this guy.
Coming in. Holding.
And so yeah, that's another sea pen, and that's in a different group. And I believe that the closest we had for this is Protoptilum. So yeah, that's two different forms. So this one here is, as you can see there, in soft sediment, and the one before was on a hard substrate. And
Was that a tiny little squat lobster that was hanging out in like a hollowed out dead sponge skeleton? Right there, yeah. Look at that.
yeah,
That's
good.
That's pretty cool.
Yeah, and it looks like Tina, Andrea, and Scott are providing an ID for that sea pen as a Helipteris.
Okay, let's come wide here. I gotta push ahead.
Roger, coming wide. Wide.
Thank you.
So my sonar shows me centered up on uphill.
I just passed. There's two of these sea pens, the two that we just imaged. There's a but it's another fish coming across the center screen there, and that looks like a Ghana stomatid. Yeah, which is what Bruce was pointing out.
Yeah, this looks like a Ghana stomatid.
Yep.
Looks like Cyclothone pallida, which is one that we've seen on occasion during these dives. It's actually a midwater fish, but I guess it gets down toward the bottom occasionally. The thing about seamounts with the vertical migration of midwater fish, during the day, as the species move toward the bottom, they encounter the bottom at the seamount, the rising, and sometimes populations can accumulate a little bit. That's thought to be one reason why there are often aggregations of larger predatory fish. Now it looks like we're looking at another juvenile synaphobranchid eel, probably the subfamily Iliophones.
Excellent. Yeah, and I don't know if you want to comment on this, Bruce, but from the sparse observation we have, it seems like the places where it's less favorable environment for corals and sponges, all of a sudden you see all these fish appearing, and vice versa. When we do see these big aggregations of corals and sponges, we see less fish.
Wide.
Any interest in the crinoid?
No, we did get a good image of that guy. Yeah.
Pushing ahead.
Sure, we've seen that thing on the left, haven't we?
So there, see a few more corals.
Not hearing any interest.
That's going to be another Eratogorgia, and yeah, this is a nice view.
So you can drop targets with F5 as
We're getting
on the
into a
ridge
nice
every
little
half hour or so.
aggregation
So we'll
here
be able to
from
track
more
the
corals.
top. Try to get an idea.
The coral to the top, that's going to be a Chrysogorgid coral.
There's another spiral.
Shallow ridge.
Yeah, ridge crest.
Ridge crest.
Yeah.
And with a squat lobster on it.
That's nice.
Yeah, and that does look Eratogorgia bella. With a commensal squat lobster. Look like Pseudomunida, possibly the squat lobster.
I mean, come wide as we get here to try and get out of this.
Mm-hmm.
Yeah, watch your port swing arm there. That's wide.
Thanks, Carl.
Depth is 950 meters now.
So you're down off the edge. This crest should be to your starboard.
Yeah, roger that.
And we see a few more corals clustered here on this. There's a few more Narella primnoid corals.
Some mucus there coming out.
That coral there to the left on that plume is again another Metallogorgia. There's two of them in view right now, and then
We've
several
got to move,
primnoid corals.
015.
015 sound good? Sounds good to me.
And not to rush anything, but if we get one more by the top of the hour, then we'll be on track.
On track. Okay.
Bridge nav.
On the bottom of the screen, we're going to have another one of those
Can we get another
long-legged
ship
shrimp.
move of 30 meters at
That's going to be in the genus
015 degrees
Nematochircinus.
at 0.2 knots. Good copy.
So again, for those folks who joined us later in the dive, we are diving today on a seamount just 20 miles outside the boundaries of the Papahanaumokuakea Marine National Monument. This is just west of Salmon Bank. This is a seamount that showed up on satellite data, but we didn't know what the topography would look like, and we mapped it for the very first time yesterday. And this is a nice view of a whole bunch of these Metallogorgia corals.
Thanks, Bridge.
So yeah, we mapped it for the very first time last night, and from that detailed sonar multi-beam image that we acquired, we were able to pick this dive site and dive on it for the very first time. And continuing on the theme for very first time, we collected our very first rock sample as well. So this rock sample will be critical for geologists to determine a couple of things about this seamount, one of them being the age of the seamount. However, there are a couple of observations that we can make to estimate the age of the seamount. So we know that in general, the seamount is either within the age range of the Cretaceous seamounts or older, in between 60 to 80 million years old, or it could be part of the Hawaiian chain seamounts, which were...
so now you can see the balance. He's stretched out a bit, and my heading...
Which are about 30 million years old, well, 25 to 30 million years old in this range.
His video wasn't
So
very good
based
because
on the overall rates of erosion and how intact this seamount is to begin with,
30
you
meters.
can try and guesstimate the age relative to the Hawaiian seamounts in the northern area. So if you had tuned into any of our dives on the younger Hawaiian seamounts, you might have noticed that we were able to pick out some more primary textures within the lava flows themselves. And as you can tell in the imagery right now, what we're looking at is a heavy cemented manganese crust that has grown over all of the primary textures and structures that are concealed under it for primary lava flow directions and indications. So that is one observation that we can make that kind of gives us the relative age of this versus a Hawaiian seamount. So kind of leaning more towards the Cretaceous age for this seamount, as well as the fact that it lies off of the axial trend along the Hawaiian archipelago. So for this to be a Hawaiian seamount, we would expect it to be located at more or less close to that axial trend of the Hawaiian archipelago, and it lies a little bit too far to the south. So all of those observations paired together, along with an analysis of the age of the rock later, will help us determine whether or not this is Cretaceous. But I do suspect that this is a Cretaceous age volcano. And again, Cretaceous meaning that it's maybe 80 to 90 million years old. And that makes it about 50, 60 million years older than the Hawaiian seamounts that are located just north of it.
Yeah, a little bit.
All right, try and follow. We've seen these.
Oh, we've seen these, yeah.
Yeah, we have.
We can come out.
All right, coming out. And so, yeah, another theme for today's dive is that we are transversing a narrow depth range that is known as the oxygen minimum layer. So about 300 or so meters wide here in Hawaii, from 1,000 to 700 or so meters, where you have very low oxygen levels. We're now at right around 1 milligram per liter. At the surface you have upwards of 7. And so we are going to see how these communities respond, and as you see different levels of oxygen. Previous work on the oxygen minimum low zone around the world has shown that in general there's a decrease in abundance of animals as you go through these areas where you have lower dissolved oxygen concentrations. But interestingly enough, some animals actually have a slight increase in abundance, and in those cases that has been attributed to the fact that there's some kind of predation release. So those might be animals that in general are controlled by their predators, and so if they are in an environment where their predators are now not able to inhabit because of the low oxygen concentrations, they suddenly are able to grow in higher abundances. So going to be very interesting to see how the fauna changes as we move and transverse this entire oxygen minimum layer. Now, Hawaii in general is considered to not have a true oxygen minimum zone. Those are typically defined in the literature as places where you have oxygen levels that are lower than 0.5 milligrams per liter. We do not get that low here in Hawaii. It's slightly above that. but it's still an area or a depth range where we do observe lower oxygen concentrations.
Nav, how are the surface wind and currents looking?
It's kicked up to
Looks like
around
we have
15
another
knots, same
Chrysogorgia
direction
right
now.
here in the center view.
And currents
And that
are
looks like it's
forward
Chrysogorgia
through the water. We got,
geniculata.
1 minute average of 0.25, and then starboard to port.
But yeah, Scott France made an interesting observation here that
pressures
about the
stayed the same.
Metallogorgia. We saw several of these
Come on in, Ed.
Metallogorgia, which and they might not be as affected as other corals, perhaps, with the oxygen minimum zone. We don't know, but we'll see as we move through this layer how the abundances change. But yeah, in the earlier portion of the dive where we landed, and then our upware ascent, it was basically only primnoid corals. What we saw was many primnoid corals, in some places even moderate to high densities. And now as we've come further up and oxygen levels have decreased, we're seeing fewer of these primnoid corals, but we're seeing fewer of other animals, but we are seeing a bunch more of these Metallogorgia corals, which are incidentally in the same family as this coral we're imaging right here.
Go ahead, Bridge. Copy that. Go ahead whenever you're ready.
It's just behind it.
Looks like the circular object, urchin skeleton, maybe. Nope.
Yeah. I don't know what that is.
Sponge.
No.
Strange.
Co-pilot looks like I was a little wrong.
There's
It's
a lot
actually
of them.
about 13 knots.
Oh,
lower
that's a
than I
different
said.
sponge.
Okay, seemed to be a gust.
Yeah.
Do you have any more zoom, or is that it?
That is it.
That's it.
Okay.
And so yeah, just to give everyone a heads up, so we are very close to the time where we expect to have the sun fade. So if we lose you in the next minute or next couple of minutes, that's what's happening. And yeah, it's this rare phenomena that's going to be occurring throughout the rest of the cruise for a brief period that we will lose satellite reception.
It's the moment where the satellite lines up with the sun.
Yeah, there you go.
So we lose the signal.
If you look at that small coral to the right, could be Antilopsamia, I'm not sure.
All right. Yeah, we'll take
The
a
one
quick
in
look
the,
for Chris.
back?
Yeah, the small one right of.
Right, come on in.
Oh, good eye, Chris. So yeah, that. Yeah, of course, unfortunately, we are pacing the wrong direction, but I think you're right, Chris, and that is a scleractinian coral, and then Analopsamia rostrata. And So back to the sun fade. So that would last about 15 minutes or so. So yeah, this is another scleractinian coral. So that's in the same order of corals, the same group that all the corals are that most people are more familiar with. The reef-building corals you see in shallow water reefs. Those are in the order Scleractinia, and they're quite rare here in the deep sea. Conversely, many groups that are quite rare in shallow water are very, very common in deep water.
Just gonna drift by here. Drifting away.
There's several ophiuroids there, and excellent. Yeah, thanks, Chris, for pointing that out.
Yeah, let's come off.
Coming out. Wide.
Depth is 940 meters. And yeah, so this ridge that we're currently ascending, it has an average slope around 45 degrees, and it does so continuously till we reach a depth of around 700 meters, and after that it's going to flatten out. The seamount is kind of more flattened at the top, and yeah, the very summit is at around 650 meters.
Quick zoom on the sponge.
Yep. So yeah, that's going to be in the Furidae family, and that's Furia near Oca erecta. And there's brittle star on there. Sponges are quite a diverse group, and a group that desperately needs a lot of people working on it. There's actually very few sponge taxonomists, and so people that work on classifying these groups to species, genera, and family. So there's very, very few people who do this, and there's so many species. One of the most species rich group of invertebrates that we know of, and so yeah, it's a group that desperately needs attention and a lot of work to be done. A lot of species, like the one right here, we have a tentative ID, so we know that this is the genus Furia, and that there's this species Oca erecta, and that this is something that resembles that, but it's not conclusively been shown that it's the same species. And next to it we have a long-legged shrimp. It's our going to be in the genus Nematocercinus.
We might be able to get an interesting shot of that shrimp from here because the sponge will act as a soft reflector for our light.
So,
come on in. We got a moment here.
yeah, we have approximately, to give everyone a heads up, approximately 4 hours remaining on today's dive of bottom time. The absolute top priority will be to make it to the top of this ridge and then spend a little bit of time right at the flat plateau area that's towards the top of the seamount. So we'll try to cover some ground here. We have
coming out now.
We're falling just
covered about 350 meters of vertical distance that we've climbed and the dive so far. And we have another 200 meters or so to go to the top.
Maybe after you reach the top of this bump, we could call it.
Here we have a few more primnoid corals, and there's another Metallogorgia, that's a chrysogorgid coral, and then it looks like a Brisingid sea star with those very long arms.
Went partial on the sea star. Pirouette around him.
Talking to me?
Yes. Sorry. Yeah, hold partial.
So yeah, that's going to be in the genus Brisinga, and then I believe the squat lobster to the bottom is a genus Munidopsis.
Have we had this organism that in the back left, that coral?
I believe so. The soft
Okay.
coral in the
Yeah.
back. We've seen the one in the back, correct?
That is correct. Yeah.
Okay.
All right.
Coming out.
Coming out.
Yeah, that's soft coral in the back. That's the mushroom coral, Anthomastus. And so yeah, primarily a deep water species. There's a bubblegum coral here, center of screen, and then top of the screen is another glass sponge, and that's going to be in the genus Walteria. Very neat animals. This particular sponge, it has this kind of lattice of fibers, the skeletal spicules, which are made out of siliceous in nature, but they're all of them are fused, and it's kind of forms this lattice-like structure. And a lot of times you have all kinds of commensals living inside of it, including some shrimp as well as ophiuroids, and in some cases, all these the skeleton of this sponge will completely trap the animals inside. So the ophiuroids will be kind of like trapped inside of it, and
Bridge nav.
but yeah, a lot of times you see a whole bunch of these brittle stars in it. Typically, you also see shrimp growing in there.
At 0.12 degrees at 0 decimal.
Coming in on it.
And on the back side of that, there's yellow arms. That's a feather star, a crinoid. And that's one of the more conspicuous species. That's going to be the species Glyptometra lateralis. And in some places, including a dive we did on this expedition, in some places they are one of the more abundant invertebrates. Today we have seen it, but not really in the high abundances we've seen it in other parts.
Thank you.
Looking at high pack, it should start to flatten out a bit after this move.
Yeah, copy.
So a beautiful view here, and
Thanks, Bridge.
yeah, those crinoids. They use their arms also to feed. They typically have mucus lining those arms, and then they will kind of use that to catch little particles that are in the water column, plankton, and then feed on that. So they have a somewhat similar feeding strategy than corals, which will do the same thing when there are tentacles in their polyps. So now we are heading due north. This gives you a little bit of sense of orientation here. So we are at a depth of 930 meters approximately, and we are looking up due north, and we see that this west flank is covered by quite a few animals, and we see a lot of these Metallogorgias. They appear to be quite common in this depth zone. We did see the same animal lower in the dive, but here it's apparently being one of the more abundant ones. And the primnoid corals appear to be a lot less abundant here than they were in the beginning portions of the dive. There you have two Metallogorgias, the one to the bottom of the screen and the one to the center of the screen. Those are the same animal. And what's interesting about that animal is that when they're young, they actually will have multiple of those plumes. They'll have 3, and they will shed them. The animal now to the right, that's Iridogorgia magnispiralis. Interesting fact about that animal is that individuals of that Gorgonian coral have been measured to be over 5 meters in height. So that's about the same size as an adult giraffe. Maybe a quick zoom on the coral to the bottom.
Bottom center.
Yep.
Copy. Coming in. All right. Whenever you're ready, Ed. I'm going to drift in on it.
And so that's also a chrysogorgid coral. Interesting.
About 130 meters an hour. Still got 500 meters till waypoint 2, which would put us there in about 3.8 hours, and we have 4 hours total. So we may want to try to kick it up to about 160 meters an hour.
Excellent.
Less lingering and more pushing, I guess. Fewer zooms then.
Are you feeling a
Yeah,
strong
copy that,
current
pilots.
from
I will,
starboard
yeah.
to port? Sure. Looks like
Yes.
this is.
Yeah.
Yeah, maybe just let me know whenever we are in kind of a spot where we
I don't
are
know if you have a move
waiting
on
for
or
a
not,
ship
but there's
move, and
another
then we'll...
vertical object. It's very small above this to the right. I'd like to try and get a quick peek at when we're done with this.
Yeah, we absolutely do want to make it to the top, if at all possible.
Yeah, copy that watch lead.
Oh, hello. There's a couple.
That guy? You looking at that
No,
guy?
no, he's not on this.
Yeah,
He's
so
on
that's very
somewhere else.
common. That's
Might be on
the
that ledge
long-legged
above that
shrimp,
I can
and
pop
we
out
did
and
get
tell
some
you where
good
he is.
video
Yeah,
of
come
him.
on out.
Yeah. Right there. Top of frame right.
Top.
Yeah, that little guy. That white, very bright, to right of lasers, and just above. Right there.
Yeah, go ahead.
Hold. Amazing how
Yeah,
on the
it's
scale
a
of
young
these
coral.
objects
Very
changes,
hard to
the associates change
get an
proportionally.
idea when they're that size.
That's true.
All right, that was all I wanted.
All right.
Thank you.
Happy watch lead?
Excellent. Thank you very much.
Okay, so I think you've kind of, the crest is to your starboard, or, well, straight ahead now, but
Yeah, copy.
my starboard.
So I'll come up.
Yeah. We'll just try to
We're
get,
changing the oil over here real quick. We'll be done in a second.
we'll try to keep you more ahead, and then we can do the next move sooner after.
Yeah, keep the ship moving, and I'll just
Yeah.
keep popping ahead and taking zooms.
I think we've had about a, I don't know, 10-minute pause after each move.
Yeah, that's too much.
Yeah.
Yeah, so we see, and this is what Scott Franz from University of Louisiana had pointed out, yeah, is that Metallogorgia appear to don't care as much as some of these other animals about the low
You're not doing your job.
concentration of oxygen. So right
I'll
now,
push a little harder.
you see that, yeah, these Metallogorgias, and for that matter, a few other that are in that same family, this Iridogorgia, are actually quite common and found in somewhat moderate densities here. Yeah, we see many of these, at least a half a dozen of these Metallogorgias in view.
There's a big coral up above you to port.
And another interesting fact about these Metallogorgia is at the center of the plume you will always see these ophiuroids, and they will always have that. And yeah, we have a massive coral, and this is a bamboo coral, and this is the first time, and that's an absolute beast. So that's probably close to
Finally.
2. Yes. That is a big coral. Yeah, so this is a bamboo coral, and that's what I mentioned as the vast majority. What we've seen so far is
Video, you want to
primnoid corals.
to get a scale on this?
And Scott Franz from the University of Louisiana, one of the world's expert on this group, has chimed in there and was very pleased to see the first bamboo coral. Well, we did see a couple of unbranched, but no big one.
Can hold that for a little while. All right, I'll leave it there.
There, come on in video on
coming in.
DT.
Daniel, this reminds me a little bit of the last bamboo coral we saw in the last dive, just before we came off the bottom, with these kind of sloping branches. It was also a very large one. We thought it was probably quite old.
Yeah, I was about to bring that up. That was very similar, yeah, and the size too, and the branching pattern.
And the density of the polyps, how many polyps there are in those branches, a lot of similarities.
Yeah.
Survey 2, can you clip Sirius camera as well, please?
And that one we had tentatively put in the Ectomyces.
I think that was long enough, right?
I don't know that we tentatively put it anywhere, actually.
Yeah.
Next move, how do you feel about your current heading there?
And I'm being a little cagey right now. I'm giving an identification.
Yeah.
Looking at the thickness of the tissue, you know, it's a little bit hard to see the skeleton through this tissue. So you can't see those dark nodes that are characteristic of the bamboo corals. I shouldn't say you can't see them. We can see them, but they aren't as obvious.
What do we expect?
So that's telling me that this is different from some of the other things that we've seen. Very often when we see these corals that have this relatively thick tissue and this sort of overall colony pattern that is it's a little bit bushy, you know, it's not in a flat plane. This could be a jasonisis or an orstomyces, but it's a little unclear at this point. Beautiful colony.
Yeah, great. Thank you, Scott.
Let them finish this guy. So I'm definitely moving.
And there's another one of these crinoids, that yellow one. That's
thank you.
Again, that Glyptometra lateralis.
See if we can get the associate
and
crab in there.
Yeah, and then a couple squat lobsters in
two
there.
of them in there, but
That's what I thought.
Yeah,
there's one off to the right, but I think we got one dead center, just inside our
and obscured from view. Yeah.
Can we come in a little more?
Yeah, go ahead.
I don't know, Mary, if she's still with us. So looking intently here.
Coming out a little bit. Holding there.
Hi, Daniel. This is Andrea. We were just looking at the hurl guide here, and it does look to be a Gastrotychus species, possibly Iapis.
Thanks, Andrea.
What was that?
Yeah, I'm gonna pull off here.
Okay, I'm coming out.
Yeah. He's very close to me.
It's a big object. Bringing your iris up. The video, can you lighten up Sirius? Sirius is coming up as well.
Yeah, quick zoom on this guy in the center.
Center, right? Yep, right there.
Oh, it's a
Femoroophuroids and
bunch of them. One maybe. At least two.
And then
that's two.
Bunch of little, what are those guys called?
Oh, it's gooseneck barnacles, scalpellets. And again, a nice illustration of the importance of corals and sponges, and in particular large corals and sponges provide habitat to all kinds of other animals. See kind of a
Thank you.
A whole community on these.
Yeah, I think
Yeah, and there's barnacles. That's also common to see that on.
Okay, are we happy, Watchley?
Yeah, perfect. Thank you. On
it's about, I think, 030.
On corals, and there's actually a group of barnacles that will
full wide.
Copy.
where the tissues of the coral will overgrow the barnacles, and it becomes a really intimate association.
Okay.
Copy that. Bridge nav.
And yeah, here's a nice view, and you can
Like
see these Metallogorgia, those
at 030 degrees
plumes, how common they are.
minutes.
And yeah, nice density we're seeing right here. This is a nice moderate density. Many Chrysogorgia corals.
A lot more current.
Good copy.
And yeah, and right as I said that, the pilot pointed out that we have a lot more current. And yeah, so that they seem to go hand in hand to places where you start seeing more dependable currents.
Coming from the east now.
And so you can use.
And things that Asako and I were just exchanging comments on. And, oh, sorry.
Go ahead, Scott.
I was saying that one of the things that Asako and I were just exchanging comments on here in the chat room was the observation of these Metallogorgia colonies.
Thank you, Bridge.
So we're noting that we also have what we call juveniles, and it's just that the colony morphology is quite different. Branches that ophiuroid, that brittle star, isn't at the top of the colony, it's about halfway down the colony. And we've done some previous genetic work that shows that these are all the same species, just different growth stages. So what we were noting is that the younger forms all seem to be about the same size, which suggests that the larvae all recruited around the same time in the past. We don't know how long it takes them to grow that size, but the fact that all of the young ones are about the size suggests they recruited. So that's kind of interesting.
Yeah, that's interesting. I mean, that's a phenomena you knew come from like terrestrial and, well, in shallow water ecology, year class phenomena where you have all of a sudden a lot of recruits all recruiting at the same time. And yeah, so you have that cohort kind of going through life, and you have, yeah, a lot of them that are in the same life stage. And yeah, in the deep sea, a lot of these ecological theories and haven't really been applied. Of course, our observations are a lot less abundant. Yeah, we have very limited observations. It's these kind of snapshot observations. You don't have the luxury of going to these places. So yeah, this is another Brisingid asteroid.
Wasn't watching my toe. Glad we got the damage waiver. There we go.
And yeah, this is a very nice, nice density.
Size of that guy.
So yeah, that's another nice mushroom coral. And yeah, this is a nice dense community, and
give you an idea of the current looking at this guy.
Yeah.
Here, zoom in. Yeah, coming in. Yep. Holding there. Wow.
Yeah, beautiful view of this mushroom coral. Anthomastus, yeah, was saying a little bit about that we have so little observations in the deep sea, and as a result we have much less information about the life history of these organisms. Very few studies.
How am I doing, Carl?
For that particular coral that we just imaged, that mushroom coral, is one of these rare cases. Is actually a species, Anthomastus atlantica, that has been kept in an aquarium, and that was work by Eric Cordes, now at Temple University, who was able to a different species once found in the Atlantic, and look at growth rates in the laboratory, and they were able to determine that they
Okeanos
kind of
those
get
have been
attain
over.
the largest sizes at an age of about 30 years. But then, of course, they continue living, and so a lot of these animals are very old.